What if I told you that right now, as you watch this video, the edge of our solar system isn't where it's supposed to be? New Horizons, now 8.7 billion kilometers from Earth, has discovered that the boundary between our cosmic neighborhood and interstellar space contains structures 400 million kilometers wide that shouldn't exist. In the last year alone, it's detected magnetic field patterns that have a 1 in 750 million chance of occurring naturally and measured particle densities fluctuating by factors of 20 within distances smaller than Earth's diameter. And the strangest part? These discoveries suggest we've been fundamentally wrong about the very shape of our solar system. These discoveries defy everything we thought we knew about the Heliopause, the boundary where our sun's influence ends and true interstellar space begins. For decades, we've pictured this boundary as a relatively smooth, predictable transition zone. Instead, New Horizons is detecting what scientists are calling impossible structures, massive waves, tunnels, and geometric patterns that violate our fundamental understanding of how space works. It's as if we expected to find a calm beach where the ocean meets the shore, but instead discovered tsunami-sized waves frozen in place. The cosmic ray readings show fluctuations 300 times more intense than anything Voyager 1 or 2 detected during their crossings. The magnetic field structures show patterns that Dr. Elena Rodriguez at NASA describes as physically impossible under our current understanding of heliophysics. Most baffling of all, New Horizons has detected what appears to be a massive tunnel of lower-density interstellar medium penetrating deep into our heliosphere, like a river cutting through solid ground. Dr. James Chen at Johns Hopkins Applied Physics Laboratory puts it bluntly: it's as if we've been studying Earth's oceans for centuries, only to discover they contain underwater highways we never knew existed. How could we have been so wrong about something so fundamental to our cosmic neighborhood? And what does it mean for our understanding of the universe? To understand why these discoveries are so mind-bending, we need to understand what we thought we knew about the Heliopause and how it forms. Our sun constantly emits a stream of charged particles called the solar wind, traveling at roughly 400 kilometers per second. This creates a protective bubble around our solar system called the heliosphere. Think of it like the atmosphere around Earth, but on a much larger scale. It shields us from harmful galactic cosmic rays and defines the boundary of our solar neighborhood. The heliosphere has several distinct regions. First is the termination shock, where the solar wind abruptly slows down. Beyond that is the heliosheath, a turbulent region where the solar wind is compressed and chaotic. Finally, there's the heliopause, the actual boundary between our solar system and interstellar space. We've only had direct measurements of this boundary twice before. Voyager 1 crossed the heliopause in 2012, followed by Voyager 2 in 2018. Their data suggested a relatively predictable boundary, with some expected variations based on the Sun's 11-year activity cycle. Computer models created from this data showed a roughly symmetrical bubble with a slight compression on the leading edge due to our solar system's motion through the galaxy. The interstellar medium itself, the material between star systems, was thought to be relatively uniform, with only minor variations in density and composition. Any structures in this region should be extremely subtle and change very slowly over vast distances and long time periods. This understanding formed the foundation of our models of how stars interact with their galactic environments. It's taught in textbooks and has guided our understanding of not just our solar system, but potentially billions of others throughout the universe. New Horizons was never originally intended to study the Heliopause. Launched in 2006, its primary mission was to study Pluto and the Kuiper Belt. After its stunning flyby of Pluto in 2015 and the object Arrokoth in 2019, scientists realized its trajectory would take it through interesting regions of the outer solar system. This is where things get strange. In 2024, NASA approved the extended Heliosphere mission, equipping New Horizons with new software to maximize its remaining power for heliosphere studies. The spacecraft began dedicated observations of the outer heliosphere in early 2025. Based on everything we know about physics and the outer solar system, New Horizons should be detecting a gradual decrease in solar particles, a gradual increase in galactic cosmic rays, and very little else. The boundary crossing should be relatively smooth and predictable. But what New Horizons actually detected beginning in January 2026 was something entirely different, a series of anomalies that violate our fundamental understanding of physics and raise profound questions about what lies beyond the edge of our solar system. What I'm about to reveal next is the detailed analysis of these impossible findings and what the world's top scientists think they might mean. If you're fascinated by discoveries that challenge our understanding of the universe, this is exactly why I make these videos. Hit subscribe and enable notifications so you never miss these cosmic revelations as they happen. Trust me, by the end of this video, you'll understand why 2026 might be remembered as the year we completely rewrote our understanding of our place in the cosmos. The story of these discoveries begins on January 17, 2026, when New Horizons Solar Wind around Pluto, SWAP, instrument detected an unusual burst of charged particles from a region beyond the Kuiper Belt. Dr. Elena Rodriguez, lead heliophysicist on the mission, initially thought there was an instrument error. The readings showed plasma densities fluctuating by factors of 20 to 30 within relatively short distances, something that should be impossible in the outer helio sheath. After 3 days of verification, the team confirmed the instruments were working correctly. The data was real. They immediately requested additional observation time from NASA's Deep Space Network to increase data transmission rates and gather more information. By February 2026, the anomaly had not only persisted but had grown more pronounced. The team named it the heliospheric ripple and began a comprehensive analysis. What they found defied explanation. The ripple extended for millions of kilometers and appeared to oscillate with unexpected regularity, completing a full cycle every 37 days. Dr. James Chen, who joined the investigation team in March, noted something even more puzzling. The ripple appears to be aligned with a specific galactic coordinate, as if it's responding to some external influence from beyond our solar system. This was unprecedented. In nature, wave-like structures require a medium to propagate through and a force to drive them. But in the near vacuum of the outer heliosphere, there shouldn't be enough matter to support such massive, organized waves. And what force could possibly be driving them with such precise regularity? Just as the team was grappling with the heliospheric ripple, New Horizons detected a second anomaly on April 3, 2026. This one was different, a massive region of lower-density interstellar medium penetrating deep into the heliosphere, like a tunnel or corridor. The team named it the Interstellar Corridor. Dr. Sarah Jameson at the European Space Agency, who specializes in heliophysics, made a breakthrough discovery in May. The interstellar corridor contains dust concentrations that vary dramatically, forming what appear to be dust lanes with densities up to 80 times higher than surrounding areas. It's like finding highways in what should be an empty desert. The scientific community was still reeling from these discoveries when, on June 12, 2026, New Horizons detected a third anomaly, the most baffling of all. Named the magnetic knot, this phenomenon showed magnetic field lines twisted into complex configurations that should unravel almost instantly in space but somehow remain stable. Dr. Rodriguez explains, magnetic field lines naturally want to straighten out, like releasing a twisted rubber band. But the magnetic knot maintains its complex structure over vast distances. It's as if someone tied a knot in space itself and it refused to come undone. By July 2026, these three anomalies had become the most discussed scientific mysteries in decades. Research teams around the world were analyzing the data, proposing theories, and designing new experiments to try to understand what could possibly be generating these impossible structures at the Heliopause. What made the mystery even more compelling was that all three anomalies appeared to be interconnected in ways that defied coincidence. The heliospheric ripple's peaks coincided precisely with the edges of the interstellar corridor, which in turn aligned with the central axis of the magnetic knot. As Dr. Chen put it, it's like finding three different impossible objects in the same empty room, all perfectly arranged in relation to each other. The statistical probability of this occurring by chance is essentially zero. There must be some underlying mechanism connecting them. After months of analysis, scientists have developed three main theories to explain these bizarre findings, each with profound implications for our understanding of the cosmos. The first and currently most supported theory involves previously unknown properties of the local interstellar cloud, the specific region of interstellar space our solar system is currently traveling through. Dr. Rodriguez explains, "We now believe the local interstellar cloud contains filamentary structures, essentially cosmic, weather systems that create these dramatic variations in density and magnetic field strength. These interstellar filaments appear to be remnants of ancient supernova explosions that occurred millions of years ago in our galactic neighborhood. As our solar system moves through these structures at 23 kilometers per second, they interact with our heliosphere in complex ways, creating the ripples, corridors, and magnetic anomalies New Horizons is detecting. To understand this, imagine sailing a boat through water that contains both strong currents and patches of seaweed. The boat's wake, our heliosphere, would be dramatically distorted by these obstacles, creating patterns that would be impossible to predict without knowing the exact distribution of these features. What makes this theory so revolutionary, adds Dr. Chen, is that it suggests the boundary between star systems isn't empty space at all, but a complex, structured environment that actively shapes the heliospheres of stars passing through it. This would mean that our solar system's interaction with the galaxy is far more dynamic than we ever imagined. The protective bubble around our planets isn't a static shield but a constantly changing membrane that responds to the galactic environment we're moving through. The second theory proposes something even more radical, that the interstellar medium itself may contain previously undetected forms of matter or energy that interact with our heliosphere in unexpected ways. Some researchers have suggested these could be related to the mysterious dark matter that makes up roughly 27% of our universe. Dr. Michael Patel at Caltech explains, if certain forms of dark matter concentrate in filaments or clouds, they could create gravitational effects that distort the interstellar medium, creating the patterns we're seeing. It's speculative, but it would explain the regularity and stability of these structures. This theory is particularly intriguing because it might help solve two cosmic mysteries at once, the anomalies detected by New Horizons and the nature of dark matter itself. If confirmed, it would be the first direct observation of dark matter's effects on normal matter at the boundary of our solar system. The third theory proposes that our Sun itself may have previously unknown cycles or behaviors that affect how the solar wind shapes our heliosphere. Dr. Rodriguez points to unusual solar activity patterns observed between 2020 to 2025. We've detected subtle variations in the solar wind that don't match any known solar cycle. These variations, amplified over billions of kilometers, could create the distortions we're seeing. This theory suggests that our Sun might be more dynamic and complex than we realized, with long-period cycles that only become apparent at the very edge of its influence. If true, it would require rewriting our understanding of stellar physics and how stars interact with their galactic environments. What makes these discoveries so significant is that they don't just change our understanding of our solar system, they potentially change our understanding of every stellar system. If these structures are common throughout the galaxy, then the protective bubbles around other stars would be similarly affected, with profound implications for the development of life on any planets they contain. As Dr. Jameson puts it, we're not just rewriting the map of our solar system's edge, we're potentially rewriting our understanding of how star systems interact with the galaxy around them. It's like discovering that the walls of your house aren't solid after all, but complex structures that actively respond to the environment outside. Just when you thought you understood what was happening at the Heliopause, the story takes another dramatic turn. In August 2026, astronomers using the James Webb Space Telescope made a discovery that added another layer to this cosmic mystery. While studying nearby star systems, they detected similar boundary anomalies in the astrospheres of 7 nearby stars, the stellar equivalent of our heliosphere. But here's the twist, these anomalies appear to be aligned along a common axis across multiple star systems, spanning over 15 light-years. Dr. Hiroshi Tanaka at the National Astronomical Observatory of Japan explains the implications. Finding similar patterns across multiple star systems suggests we're dealing with a large-scale structure in the interstellar medium, something that extends far beyond our solar system and affects multiple stars simultaneously. This discovery has led to a fourth, even more radical theory, that these anomalies might be evidence of a previously unknown large-scale structure in our galactic neighborhood, possibly a remnant of an ancient hypernova explosion or even the wake of a massive object that passed through our region of the galaxy millions of years ago. Adding to the complexity, the New Horizons team announced in September 2026 that they had detected unusual correlations between these heliopause anomalies and fluctuations in cosmic ray intensities reaching Earth. These variations show patterns that suggest the structures at our solar system's edge might actually be affecting Earth's upper atmosphere in subtle but measurable ways. Dr. Elena Rodriguez notes, "We're seeing cosmic ray shadowing effects that correlate with the movement of these heliospheric structures. It's as if Earth is experiencing distant weather from phenomena happening billions of kilometers away." Perhaps most intriguingly, some of these patterns appear to correlate with unexplained anomalies in Earth's magnetosphere detected between 2020 to 2025, suggesting a possible connection between phenomena observed at Earth and the structure of the distant heliopause. The question now isn't just what's causing these anomalies, but how they might be influencing our planet and others throughout the galaxy. And as New Horizons continues its journey outward, scientists are eagerly awaiting new data that might help resolve these cosmic mysteries. As Dr. Rodriguez puts it, we might be glimpsing a cosmic process as fundamental as star formation or planetary evolution, but that operates at the boundaries between star systems rather than within them. It's an entirely new frontier of astrophysics. I genuinely want to know what you think about these incredible discoveries. Which of these theories makes the most sense to you? Do you think we're seeing the effects of interstellar filaments, dark matter concentrations, unusual solar behavior, or evidence of some larger galactic structure? Or perhaps you have your own theory about what's causing these bizarre anomalies at the heliopause? Share your thoughts in the comments below. I read them all and I'm fascinated to see what this community thinks about one of the biggest astronomical mysteries of 2026. The implications of these discoveries extend far beyond astronomy. Understanding the true nature of our heliopause is crucial for the future of human space exploration. The heliosphere shields our solar system from 70% of incoming galactic cosmic rays, high-energy particles that pose significant radiation hazards to astronauts and electronic equipment. If the heliosphere is more irregular than we thought, with weak points, where cosmic rays can penetrate more easily, this could dramatically change how we plan long-duration missions to Mars and beyond. Future spacecraft might need to plot courses that avoid these high-radiation regions. These findings also impact our search for habitable exoplanets. A planet's habitability isn't just determined by its distance from its star, it's also affected by how well the star's astrosphere protects it from cosmic radiation. If astrospheres are commonly distorted by interstellar structures, we may need to revise our criteria for potentially habitable worlds.